Welcome to the first video of Chapter 11. We're going to start by making a chart of the perfect squares. Even though we know you know them all, we're going to make it so we have it and we can reference it very easily. So 1 squared obviously is 1. Our next perfect square is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Now, Miss Cash is having a Friday afternoon moment and wrote 110 is the perfect square of 10. And I know you all were just freaking out, but we caught it. It's fine. A lot of people want to know, do you have to have these memorized? Of course you have to have these memorized. We're just putting them here so when we're learning this new topic, you have them to reference. So what we're going to be doing today is we're going to be simplifying radical expressions. Last chapter, we would actually type into our calculator the square root of 12, and we would get whatever that was. However, that's an approximation since we have to round that irrational number. So we're going to go ahead and show you how to simplify radical expressions. So our steps are written right there. So when it says try to factor out a perfect square under the radical, we're looking at the square root of 12, and we're thinking what perfect square goes into 12. We're going to start with this easy one. It's easy. 4 times 3 is the same as 12. So we're going to leave 4 times 3 under our square root. And now if we're taking the square root of it times together, we're going to break it apart to 4 times 3. Now we can actually evaluate the square root of 4 is 2. And we'll just leave the square root of 3 because it's not a perfect square. And that is going to be our answer. And we know that that looks far different than anything that we've seen. Although I did have a couple people ask me when we did the NISA about that Pythagorean theorem problem, and that's where they were getting that number from. Okay, so the square root of 27, we're thinking what goes into 27 that's a perfect square, and that's going to be 9 times 3. And then we'll break that apart to the square root of 9 times the square root of 3. Well, the square root of 9 is 3, and we can't do anything to the square root of 3, so there we go. So that's saying 3 times the square root of 3. And if we were to type that into a calculator, we would get the same thing as if we were to do the square root of 27 on a calculator. Square root of 90, our factors that go in will be 9 times 10. And then we'll do the square root of 9 times the square root of 3. Oh, I'm sorry, times the square root of 10. My goodness. 3 root 10. Doesn't matter what order you write them in. Generally, we will write them with the perfect square first, just because that's the way my brain works. All right, square root of 20. What goes into 20? Think. That would be 4 times 5. Square root of 4 times the square root of 5. Square root of 4 is 2, so we will have 2 root 5. Those of you, I get a lot of questions, well, why couldn't I do 2 times 10? Neither 2 or 10 is a perfect square, so it's not going to do us any good to break it down to 2 times 10. We always want to think what perfect square goes into the number under the square root sign. Onward. Okay, let's talk about when we're using variables. When we're simplifying expressions with variables, we need to think, what's the perfect square of something with a variable? So if we do x squared times x squared, that's saying that that's x to the 4th. So remember, we do our exponent rules, so it's x to the 4th. So if we're doing x to the 3rd times x to the 3rd, that's x to the 6th. X to the 4th quantity squared would be x to the 8th. Hopefully you're seeing your pattern that we're just doubling the exponent to square something. So this means anything with an even exponent is a perfect square. So to get the square root, we're simply going to divide the exponent by 2. So when we try and take the square root of x to the 8th, we're trying to think what times itself is x to the 8th, or we can just say x to the 8th, we can just divide it by 2 and do x to the 4th is the square root. Oh, she is Fridaying all over this. So we'll just write x to the 4th. So then when we want to take the square root of x to the 12th, we're going to take and divide by 2. And we're going to get x to the 6th. So x to the 20th, 20 divided by 2 is x to the 10th. And x to the 80th, half of 80 is 40. So those problems right there, we've gone ahead and done all of those. Now, the even exponents are perfect squares. Unfortunately, odd exponents are not perfect squares. So in the same way we factor numbers under radicals in order to pull out the perfect squares, we're also going to do that with variables. So we're going to make x to the third, we're going to break that down to x to the second times x. Because that would make sense. 2 plus 1, that would give us 3. We're just separating the terms. And now we can go ahead and do what we did before. So the square root of x squared is x. We're dividing it by 2, and x to the first is not a perfect square, so we're going to leave that under the radical. Let's try that again with x to the fifth, the square root of x to the fifth. We'll break that down to x to the fourth times x to the first. And then we'll separate that. 4 divided by 2 will give us x to the second root x, and that's our answer. Again, x to the seventh, we'll break that down to x to the sixth times x, and the square root of x to the sixth is x to the third root x. Now hopefully we're seeing a pattern here, that to take the square root of all these odd numbers, we're always going to leave an x to the first, so x to the 20th times x to the first, and then we'll have x to the 10th square root of x. Go ahead and take a minute. You can pause the video and try and write your summary on how to take the square root of variables with an odd exponent. Now we're going to talk about multiplying terms with radicals. The product of two square roots is equal to the product under one square root. So basically we're going to take these two square roots and we're going to squish them back together. So the square root of 3 times the square root of 2 is the same thing as putting 3 times 2 under one square root, which is 6. Now we have to be careful because we have to make sure that that's simplified. Do any of our perfect squares go into 6? No, they do not. So the square root of 6 is going to be our answer. Square root of 3 times the square root of 15, that's the same thing as putting 3 and 15 underneath one radical. So that's going to be the square root of 45. We're thinking what goes into the square root of 45, and 9 does. So we're now going to simplify this like we were doing on the front page. So 9 times 5, and then we'll break that to the square root of 9, which is 3 times 5, and there's our simplified answer. Oh, I see what you're doing, showing a little extra work. I like it. Okay, last one on this section. Square root of 2 times the square root of 12 is 2 times 12 under the square root, which is 24. What goes into 24? That would be 4 is our perfect square, so 4 times 6. And then we're going to make that the square root of 4 times the square root of 6, so 2 root 6. And the last thing we're going to talk about is going to be what happens when we're doing some more multiplication. So we're going to talk about, you can fill in those blanks if you would like. I think it's easiest if we have d square root of a times c square root of b, that's the same as d times c times a times b. So basically we're multiplying the outsides, multiplying the insides. Okay? So when we look at our first example here, 2 root 3 times 4 root 7, we're going to do 2 times 4, and that stays on the outside. And then we're going to do the square root of 3 times the square root of 21, or times the square root of 7, spoiler alert, which is the square root of 21. And that stays on the inside. So when we put that together, it's going to be 8 square roots of 21. And before we circle our answer, we need to make sure, do any perfect squares go into 21? No, they do not. So we can go ahead and circle that that is our answer. Bam! I like it. Okay, number 2. 5 root 2 times 4 root 8. So we're doing 5 times 4, which is 20. Root 2 times root 8, which is the square root of 16. The square root of 16. What is that the same as? Oh wait, the square root of 16 is 4. So that's the same as 4 times 4 under there, so we're going to say that that is, square root of 16 is 4. So we're going to do 20 times 4, and our whole answer is going to be 80. If we were to have written our answer as 20 times the square root of 16, that's not complete because we need to actually evaluate the square root of 16 because it's a perfect square. And now, number last. We have our outsides and our insides, so we're going to do 3 times 4, and that's going to give us 12. And then we're going to do square root of 2xy times the square root of 6x. So 2 times 6 will give us 12. X times x will give us x squared, and then the y has no one to multiply with. So we have 12x squared y. Now, if we try to write this as 12 times the square root of 12x squared y, that's not going to be all the way correct because we can simplify 12 and we can simplify x squared. So the square root of 12 simplifies to 4 times 3, which is 2 square root of 3. And the square root of x squared, that is a perfect square, so that just simplifies to x. And the square root of y is just the square root of y. Now we can take our simplified problem and we can't forget about our 12. We're going to put all of our outside stuff in front, and then we'll put all of our inside stuff inside. So 12 times 2 times x, and then underneath our square roots we have 3 and y. So our final answer will be 24x times the square root of 3y. Now I know you're thinking, this is possibly the best thing we've done all year. And I would agree, maybe. We're going to spend 3 days this week working on this, and we're going to get lots and lots of practice in class. We would like you to try the 6 problems that are listed below there. We know the last one we did was a little difficult, but you should be okay to try A, B, C, D, and E without too much difficulty. So go ahead and give those a try. Ms. Cash is nice enough to write those up there for you in the event that you have forgotten your note sheet at school. If there was something that you really were confused about, it would be a good idea to go back and either highlight it or write yourself a note off to the side so you know what you want to ask when you get to class on Tuesday. All right, there you go. Enjoy your evening.